Now we'll see how to find the transpose of a matrix using C program. So first let's try to understand what is a transpose of a matrix. So if we have a matrix say A with elements A, B, C and D, E, F. So here we can see that the matrix is a 2 by 3 matrix, that is it has 2 rows and 3 columns. So if you find the transpose, it becomes a 3 by 2 matrix. Okay, so that is it has 3 rows and 2 columns. So how do we actually find the transpose of a matrix? We can find it by changing the rows into columns and columns into rows. So if we look at this particular example, it's A, B, C, which is the first row here, gets converted, the row gets converted to column. Okay, first row to first column and second row to second column. Or if you look the other way, the first column here AD becomes the first row here, second column second row, third column third row. Okay, so if you want to know more on this, you can look to this particular source from where I have taken these examples. So another example, if I look here, this is a 4 by 5 matrix and its transpose is 5 by 4. So if you look the color code 1 2 3 4 5 has become, which is the first row here, has become the first column here, 1 2 3 4 5. Similar with other cases. So let's see how does a computer actually look to a transpose problem. Okay, so matrix as usual is stored in a 2-dimensional array, and for the indices actually start from 0. Okay, so this is a 4 by 5 matrix and its transpose will be a 5 by 4 matrix. So here if we take any particular element, say M12, say I am calling this as M, the matrix, and this is a transpose T. Okay, so if I am giving that nomenclature, what is the element at M12? So if this is the matrix, M1 is here, this particular row, and M12. So okay, 8 is the value here. So M12 has a value of 8. So let's see where this 8 has gone to in the transpose. In the transpose here we find 8. So which is this? This is T21. Okay, T21. So M12, the value there in M12 has gone to T21. Okay, and the next one is M33, which is the value in M33, 19. 19 is the value in M33. And where do you find in the transpose matrix? That again is in T33. Okay, so there is no change, it's the same position. Okay, and when we look at M03, where is M03? M03 here, and what is the value there? It's 4. And where do you find 4 here? It's in T30. Okay, it's in T30. Okay, so if we analyze these values there, so M12 has become the value in M12 has gone to T21. So 1 2 to 2 1. So it has become the opposite. Okay, 3 means it's the same, there is no difference, and 03 has gone to 30. Okay, so just like say we look to transpose, and in transpose rows get transformed to columns and columns get transformed to column. So in a similar manner, so if we look at a particular index, the row and the column gets swapped here. So 1 2 gets transformed to 2 1 with the value 8 or 19 4. So in all the cases we see that that's true. Okay, so we'll be using this particular property to write the program to find the transpose of a matrix. Okay, so if you look the entire sequence, so we can actually tell that there are 5 major steps that are involved to actually read a matrix from the user and to display back the transformed matrix back to the user. Okay, so the first so for example, let's consider that the user is planning to give this particular matrix M, and the program is actually supposed to give back this particular transpose as the output back to the user. Okay, so the first step is to read the matrix row size and matrix column size. So here, if the user is planning to enter this particular matrix M, what is the row size? The row size is 4 because it's 1 2 3 4 rows are there, and the matrix column size will be 5 because we have 1 2 3 4 5 columns are there. Okay, so once we have the row size and the column size, we can use 2 for loops and we can enter all these 20 values. Okay, so that is the first part. So we have this particular matrix M full or it is fully read right now. So now we have to look how do we develop the matrix, or how do we make the transpose of the matrix. So for that, again, first we need the number of rows and then again number of columns. So from all the examples that we have seen, we know that the row size of the transpose matrix is the column size of the original matrix. Okay, so here the matrix initially had 4 rows, so the transpose will be having 4 columns. Okay, in a similar manner, if the rows and columns, both of them will be swapped. So transpose row size is equal to matrix column size, and transpose column size will be equal to matrix row size. Okay, and so now we have this the size, we know what's the size of the transpose matrix. So the next step is to actually fill in these values inside. Okay, for filling it, what is the simple formula there? T of row column is equal to M of column row. So if you want to find what is the value in T21, what should we do? We should go and look what is there in M12. Okay, and we can write it there. Or if it is T30, what should we where should we look for the value that we had to write in T30? We had to look in M03. Okay, you look to M03 and you know what you have to write in T30. So that's it. So for each element in the 5x4 matrix, you will have to look for the value in the M matrix and then just write it there. Okay, so once you have all the 20 values, the transpose is complete, and the last step is to display the transpose matrix. Okay, so now we'll look at the program, and the first part is to read the size of the matrix. So here we have declared our matrix M, and our transpose will be written into this two-dimensional array T10 of 10, and this variable matrix row size and matrix column size, these are for entering the row and column size of the matrix, and transpose row size and transpose column size for storing the row and column size of the transpose matrix. So in the first step, they are asking to enter the number of rows in the matrix, that which is stored in matrix row size, and after that the user is prompted to enter the number of columns in the matrix, and that actually is stored to matrix column size. So this is about reading the size of the matrix M. Okay, so once we have that, what do? We actually read the matrix. Okay, so for that, this is quite familiar for you right now. So we have row equal to 0, less than matrix row size. So this make sure that all the rows are getting read, and here within each row we have multiple columns. Okay, so from row equal to 0 to column less than, from column equal to 0 to column less than matrix column size, we actually enter each elements one by one. So once that is over, what do? We have to again find the values in the transpose matrix. So the first step is to find the transpose row size, that is the same as matrix column size, and transpose column size is the same as matrix row size. Okay, so the size of transpose is decided, and now what do you have to find? We have to find the values that are associated with the transpose. So for that, again we write the two loops. Here the row will, instead of the matrix column size will be, or matrix row size, here we will be using the transpose row size, and for the column we will be using the transpose column size instead of matrix column size. Okay, and what is the value for T row column? Where do we get the value from? We get the value from M column row. Okay, so with these steps we actually get the values of the transpose. Now the only thing that is left is to display the matrix that the user has entered. So for these steps would be enough for that. Print of the matrix you have entered is, and then for each row we give a new line, and for each number that you print out you will give a tab, so that with this we can make sure that the value that you're printing out looks like a matrix. So once the matrix is printed, the next step is to print the transpose. So for that, again you follow this exactly the same steps, except that this matrix row size get changed with transpose row size, and matrix column size get changed with transpose column size, and the value that you're actually printing is here it's from transpose T, and earlier it was M. So that's it. So that's the program. So now let me just show you the program. This is a program that I've run, that I've created. So let's just try running it. Okay, so the first thing that they are asking is the number of rows. So let me just give it as rows as 3 and the number of columns as 2. So the elements 1, 2, 3, 4, 5 and 6. Okay, So I have entered the matrix. So here the program is over. It's showing the matrix you entered is 1, 2, 3, 4, 5, 6. Why? Because I had said them that the number of rows is 3 and number of columns is 2. So number of rows is 3 and number of rows is 2. So that's correct. And the transpose, okay, so because this is a 3 by 2 matrix, its transpose will be 2 by 3 matrix. So we are having 2 rows and 3 columns. So that part is right. And so now again we have to check 1, 2. 1, 2 is the row here, has become the column. 3, 4 to a column. 5, 6, the last row has become the last column. So that's it. So we have learned what a transpose is and how to find the transpose of a matrix using C programming. Okay, thank you.